This is coordinate geometry, and as you can see to the left, you have certain figures, namely rhombus, square, parallelogram, rectangle, trapezoid, and an isosceles right triangle. You're going to use these methods in which to prove whether you have these figures or to prove that you do not have these figures. So you can prove that you do have or don't have. More than likely, you'll be proving that you do have a figure. So you'll be told which ones in order to prove. We are going to practice proving all of them. And to the right, as you can see, it's got some ways in which to prove. And in some cases, you can prove things using one out of two methods. So, for example, the first one, the rhombus, we need to show that you have four sides equal in length. So one of two ways in which to do that is to use the Pythagorean Theorem. So you're going to have to make right triangles out of the sides, or you can use the distance formula. I choose to use the Pythagorean Theorem. I think it's just an easier method. It's a nicer method as opposed to the distance formula. With regard to the square, you need to show that it's a rhombus, so all four sides congruent with one right angle. And in order to do that, you need to show that you have perpendicular slopes. So to show that four sides are equal, it's one or the other, Pythagorean theorem or the distance formula. In a parallelogram, you need to show opposite pairs of sides are parallel, or you can show that opposite sides are congruent. You have a choice. In a rectangle, we know that opposite sides are congruent and it also has a right angle. Or you can show that opposite sides are parallel. Okay, so you're going to use two out of these three. With a trapezoid, you have only two sides that are parallel, so you're going to show that. You're going to show that two sides are not parallel. Okay, so you'll either be using the distance formula 4 times, or you can use Pythagorean theorem 4 times in order to do that. And to show that you have an isosceles right triangle, you need to show that two sides are congruent and that you have one right angle. In order to show that you have one right angle, you need to have negative reciprocal slopes. That shows perpendicularity. So we have quadrilateral PQRS that has vertices P 34, Q 86, R 99, and S 47. Prove that PQRS is a parallelogram. So in order to do that, I need to show opposite sides parallel, and if that's the case that we're going to use, then we need to show that we have equal slopes, or we can show that opposite sides are congruent. We're going to go with opposite sides are parallel. So the first thing I would do is graph. So we're going to graph the points. Okay, so you use the straight edge in order to connect the points and to make your quadrilateral. I unfortunately don't have that availability. Okay, so what we want to do is show that SP is parallel to RQ. And we also want to show that SR is parallel to PQ. Okay, so using slope, the change of y over the change of x. So for SP, I have 7 minus 4 over 4 minus 3, and I get 3 over 1. And for RQ, nine minus 6 over 9 minus 8, and I get 3 over 1 as well. So we have just shown or proven that SP is parallel to RQ, so we're halfway there. Now for SR, I have 9 minus 7 over 9 minus 4 that's equal to 2/5. And for PQ, I have 6 minus 4 over 8 minus 3, and I also get 2/5. So this works as well. Now I need to write a final statement. PQRS is a parallelogram because opposite sides are parallel with equal slopes. Okay, so you have to make sure you make this final statement. Next. In this case, we want to prove that quadrilateral PQRS is a rhombus. So the first thing we're going to do is graph these points. Okay, so if ever you have to graph something that's not on the coordinate plane or it's extended out, you could always extend your Cartesian plane. And I'm going to do the best that I can in order to draw these lines in here, but you don't do that. You make nice straight edges using your ruler. Don't ever freehand something in geometry. So we got a nice looking diamond here. And in order to prove that I have a rhombus, I need to show that all four sides are equal. So at this point in time, you can use the distance formula if you feel very comfortable with it 4 times and show that PQ is congruent to QR and that's congruent to RS, and then finally PS. I'm going to use Pythagorean's theorem. And in order to do that, I need to create my right triangles. So I'm going to create my right triangles outside so that I can count up each of these boxes very nicely for the legs of my right triangles. Okay, so now I can go ahead and count 1, 2, 3, 4, 5 for the top here, and then for this other leg, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. 1, and 5. 5 and 12. 12 and 5. And the great thing is that each of these triangles have the same lengths for their legs, so it's 12 and 5. So now I'm just going to put it into Pythagorean's theorem. A square plus B square equals C square. So 12 square plus 5 square is indeed equal to C square. 144 plus 25 equal to C square. 169 is equal to C square. Take the square root of both sides. Reject the negative, accept the positive, 13. So the length of each side is equal to 13, and as a result, we can write our final statement. The length of each side of rhombus PQRS are congruent. Actually, let's take out rhombus. So the length of each side of PQRS are congruent, therefore PQRS is a rhombus. We will rephrase that. Okay, in this case we need to prove that we have a square. In order to do that, we need to show 4 sides equal as well as a right angle. In order to show that you have one right angle, you need to take 2 sides that intersect and show that you have negative reciprocal slopes. So I'm going to go ahead and graph first and see what I've got as far as the figure is concerned. Again, you use a straight edge in order to graph or draw your lines. I'm going to use Pythagorean Theorem in order to show all four sides are congruent. Okay, so each of these triangles have lengths of 2 and 5 for their legs. So I only need to show that once in the Pythagorean theorem substitution. So 5 square plus 2 square is equal to c square. So the square root of 29 is equal to c. That means jk is congruent to ki, which is congruent to IH, and that is congruent to HJ. Okay, so now negative reciprocal slopes in order to show perpendicular sides. So I'm going to go with side JH and HI. So we want to show JH is perpendicular to HI. Okay, so the slope of JH. So 7 minus 2 divided by 1 minus 3 is equal to the difference of negative 5 halves. And HI, ultimately we want to get 2/5. So 4 minus 2 and 8 divided by, or subtract 3. And that does give us a slope of 2/5. So we do in fact get negative reciprocal slopes, so we've just shown that these two are perpendicular. Now we need to write a final statement. HIJK is a square because all sides are congruent and we have negative reciprocal slopes. Okay, we need to prove that we have an isosceles trapezoid. So I need to show one pair of sides congruent, so those would be the legs. one pair of sides parallel and one right angle. So I'm using slope twice in order to show that we have a parallel sides, in order to show that we have one right angle, and we also are probably going to use the distance formula in order to show congruent legs, or you can use the distance formula if you should choose. So let's go ahead and graph this. P is negative 8, 2. Q is 0, 6. R is 8, 0. And S is negative 8, negative 8. Again, use a straight edge instead of freehand like I'm doing. Not too bad for freehand. But regardless, the best case scenario is to use a straight edge and make them nice and perfect. Okay, so the two sides it appears that I want to show congruent are PS and QR, those legs. Okay, so I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. PS is 10 if you count because that's a nice straight edge, but QR is not a nice straight edge, so I'm going to have to make a right triangle here and use the Pythagorean Theorem and show that I get 10. Okay, so 8 squared plus 6 squared is equal to c squared. 64 plus 36 equal to c squared. 100, or the square root of that, is equal to c, so c is equal to 10. And we can say that 10 is equal to 10, so this works out. I need to show that I have one pair sides parallel, so that means I'm going to go for PQ parallel to SR. Okay, so 6 minus 2 for PQ. Zero minus a negative 8 is plus 8. So 4 eighths is equal to 1/2. And I need to get that for SR. Okay, so 0 minus a negative 8 is 0 plus 8. Divided by 8 minus a negative 8 is 8 plus 8. So this is 8 over 16, and that's equal to 1/2. So there's my parallel sides. I'm actually not going to show that I have a right angle because I'm not asked to show that this is an isosceles right trapezoid. I'm only asked to show that it's isosceles trapezoid. So I'm going to scribble this right angle out. So I have enough information to show that I do have, in fact, an isosceles trapezoid. Okay, so PQRS is an isosceles trapezoid with two congruent sides and one pair of parallel sides. Okay, that's my final statement. Okay, here's where I want to prove that I have an isosceles triangle. That is right. Okay, so the coordinates of triangle BUG are 1, 3 for B, 8, 2 for U, and 5, 6 for G. Again, you use a straight edge. It looks like BG and GU are the perpendicular parts. And it looks like those two would be the two congruent sides. So I'm also going to show that they are congruent. Okay, and that means I need to form some right triangles here. 3, 1, 2, 3, 4, 3, and 1, 2, 3, 4. Okay, so 3 square plus 4 square is equal to C square. 9 plus 16 is equal to C square. The square root of 25 is equal to C. So C is equal to 5. Okay, so I just proved that these two sides are congruent. And now its slope for BG, 6 minus 3 over 5 minus 1. So I get 3/4. And for GU, 6 minus 2 over 5 minus 8. And I get -4/3. So these, in fact, are negative reciprocal slopes. That means they're perpendicular. So I have enough information to make my final statement. Triangle BUG is a right isosceles triangle because two sides are congruent and there is one right angle. And then the final thing we're asked to do is to find the area of BUG. So the area formula of a triangle is 1/2 base times the height. So we know that the base of this triangle, BG, is 5, and the height, GU, is also 5, because it's isosceles. So this is 5 times 5 divided in half. So 25 divided in half is equal to 12.5. A lot of work for one problem. And lastly, I'm asked to prove that quadrilateral PQRS is a trapezoid and not an isosceles trapezoid. So that means I'm going to show one pair of opposite sides that are parallel and that the legs are not congruent. So the first thing I'm going to do is plot the points. Again, you use a straight edge in order to do this. I'm going to have to show that these two legs are not congruent. So this one I can just count. 1, 2, 3, 4, 5, 6, 7. This one I have to use Pythagorean Theorem. So QP is not equal to RS (4 squared plus 5 squared is equal to C squared). 16 plus 25 is equal to C squared. 41 is equal to C squared. C is equal to the square root of 41, which clearly is not equal to 7. And then we want to show that QR is parallel to PS. So that's slope formula. 6 minus 4 divided by 1 minus a negative 3 is 1 plus 3. So that's equal to 1/2. That's for QR. And then for PS, that's 1 minus a negative 3, which is 1 plus 3, over 5 minus a negative 3, which is 5 plus 3. 4 divided by 8, which is equal to 1/2. And we have now shown that we have parallel sides because the slopes are equal. So at this point in time, we have effectively shown that PQRS is a trapezoid because one pair of parallel sides, but it is not isosceles because the legs are not congruent. And that's the final statement. There's a packet for you to practice these that will be provided to you in class.